Okay, so the level of happiness in a marriage, assuming that two people didn't have a good marriage, go to counseling, and 1 would mean not happy at all, 10, you're happy. So it is claimed by critics that there is no effect whatsoever because of counseling. So to verify, we have this data. But there are some cases they went in sort of happy. After the counseling, they decided, oh no, I'm actually miserable. So if we go with the same strategy of having after minus before, what test will you perform? Should you perform?
Left tail.
Right, huh?
Left tail.
Left tail, why?
Not sure. Because the right tail would be before minus after.
I'm defining it as optimal. Oh no, that's not true. So if it is a left tail test, you want more negatives. In other words, the after has to be less than before. If we did a left tail test, we will conclude that there is no effect at all. But if you look at the wording of question, we're not interested in whether it goes up or it goes down. The critics are just saying it doesn't matter whether you go to counseling or not. It doesn't change the level of happiness. So which test would you use? 2 tests. So the law is theta equals 0. Alternative, theta not equal to 0. There is nothing wrong with, what Chris said, doing a left tail test, because we have a scenario here where we don't care if it decreases or not. All I'm interested in is it's not the same. So it could go either way. And one may ask, well, if that is our conclusion, how would one say counseling actually benefits people? Well, after you do the 2 tail test, you see where the test statistic lies. If it lies on the right-hand side, if the test proves to be significant, then it's better. If it lies on the left-hand side, worse. Yes, so a 2 tail test often is a good way to go. So after minus before, 7 minus 1, 6 minus 4, 2 minus 3, 2 minus 1, 8 minus 4, 3 minus 1, 2 minus 3, 2 minus 6. Good. Yes.
The second negative one should be present.
This one?
2 down.
2 down. 2. Bad. Good. Now we want to assign ranks, but in order to assign ranks, we've got to, we'll do side I first. 1, 1, 0, 1, 1, 1, 0, 0. The absolute value of Zi 6, 2, 1, 1, 4, 2, 1, 4. rank, I want you to assign the ranks and tell me what T plus is. Your book does everything based on T plus. So assign the ranks and tell me what T plus is. Okay, so whole bunch of ties here, so we've got to be careful. So when we start, I see ties, 1, 1, 1. If they weren't tied, I would have assigned the ranks 1, 2, and 3. Since they are tied, I'm going to assign the average of those ranks. What is the average of 1, 2, 3? It's 2. Yes. Hypothetically, I've assigned 3 ranks, which would mean the next rank that I should assign is 4. So I look at 2 here, there are 2 2s. If these were to be different, I would have assigned 4 and 5. But since they are the same, the average of 4 and 5 is 4.5. So now I've assigned 5 ranks, 1, 2, 3, 4, 5. So the next one is 6. So I go over to the next magnitude, which is 4. There are 2 4s. If they were different, I would have assigned 6 and 7. Since they are the same, I'm going to assign the average of 6 and 7, which is 6.5. The last rank must be 8 because I've assigned 7 ranks. So 8. Good. So to find T plus, all we are doing is multiplying psi I with Ri and adding them all together. 1 times 8, 8, 1 times 4.5, 4.5, 0 times 2, 0, 1 times 2, 2, 1 times 6.5, 6.5, 1 times 4.5, 4.5, 0, 0. Effectively, what we're doing is we are simply adding the ranks corresponding to positive signs. Yes? So if you add them all together, you get 10, 21, 26, 9, 10, 11, so 19 plus 6.5. 23.5. Yes. Good. What should the rejection region be? Or where should the rejection region be? So T plus is 23.5.
25.
25? Oh, yeah. 25.5. 19 plus 6.5. Where should the rejection region be in this case? Should it be on the right, the left, both sides? Both. So there is a rejection region over here, rejection region over there. Yes, I'm using the notation T alpha over 2 plus to indicate the critical value on the right. T alpha over 2 minus to indicate the critical value on the left. 0 is right in the middle. How do we find the critical values? People would end up saying, oh, I would just add the area below the curve and area above, area below the test statistic, area above the test statistic. Well, if you did that, you'll get 1, right? So what we have to do is to find T minus to get the other side. If T plus is 25.5, what is T minus? How do we find T minus? what is the total sum of all rungs?
Said the negative range, right?
8 times 9 over 2.
8 times 9 over 2. It's the sum of all the rungs. So 8 times 9 over 2 is 36. Yes? So the total value, T, is 36. And we know T plus added to T minus would be equal to T, sum of all the rungs. How did we get 36? We did n times n plus 1 over 2. So 8 times 9 over 2. 25.5 is T plus, which would mean T minus is 36 minus 25.5. We'll get 10.5. Add the area above the test statistic, which would be the positive test statistic, area below the test statistic, the negative test statistic. So what function in R should we use to find the area above the P sign bug? NSA. By default, R is going to give you the area below, but you can force it to give area above by typing lower dot tail equals false, or you can just do 1 minus, entirely up to you. So the area above the positive test statistic, T plus, is 0.125. The area below on the other side is simply the area below, so we shouldn't type lower dot tail equals false. That ends up being 0.191. It's 0.316. Is the p-value less than alpha? No. Alpha is 0.1, p-value, exact p-value is bigger than 0.1. So we do not reject null. Good. We want to do the large sample approximation. So what do we need in order to perform large sample approximation? The mean, which is Chris. What?
It's
Mean is not Chris.
it's 8 times 9 divided by 4.
Very good. So it's n times n plus 1 over 4, 72 over 4, which is 18. The next step is to find the variance. Variance is tricky in this case. If we did not have any ties, variance is easy. It is simply n times n plus 1 times 2n plus 1 divided by 24. Yes? Since we have ties, there is an additional term Yes. So how many groups do we have? tide groups? Well, 1, 2, 3, 4. Yes, there are 4 of them. So T1 would be the tide rounds 2. How many do we have in the group that is tied? We have 1, 2, 3. So the number of ties in the first group is 3. Can I erase this side? So T1 is 3. The next set of tide rounds, the second group, is 4.5. The number of rounds in the second tide group is 2. What is the number of rounds in the third tide group? 1. What is the next round after 4.5?
2.
Two.
There's 2 in there.
Okay, 6.5, right? How many 6.5s do we have? 2. So the next tide group will have 2. The last one, T4, has only 1, which is rank 8. Even if you made some mistake, if you accidentally make a mistake in coming up with this, you can always add these values and it has to add up to n, which is 8. If it doesn't, you made a mistake somewhere. But so the variance is 8 times 8 plus 1, 9. 8 times 2, 16, plus 1, 17, divided by 24, minus we have 4 groups. So when I is equal to 1, I will get T1, T1 minus 1, T1 plus 1. Yes, for the first group. When I is equal to 2, T2 times T2 minus 1, T2 plus 1. When I equals 3, T3, T3 minus 1, T3 plus 1. Yes?
So you're adding all 3 of those together?
Yes.
Okay.
And I'm ignoring T4. Can you tell me why?
Because it's just 1.
It's just 1. You plug it in that formula, it'll become 0. So I don't care. The first term, wait, 51. So 51 minus 1/2. T1 is 3. 3 times 3 minus 1, 2. T plus 1, T1 plus 1, 4. T2 is 2. So 2 times 2 minus 1 is 1. 2 plus 1, 3. T3 is the same thing. So 2 times 1 times 3. Because T2 and T3 are 1 and the same. So 31 minus 1/2, 24 plus 6 plus 6. 36, which is 18. I get 33. Good. That is the variance. Should we use the variance or standard deviation in our formula? Standard deviation. If the variance is 33, what is the standard deviation? How do we find the standard deviation? Take the square root. So the standard deviation square root of 33, which is 5.774. So square root of 33, 5.74. The test statistic for last sample approximation is simply t plus minus the mean divided by the standard deviation as that score of the test statistic. We know what t plus is. From earlier, t plus was 25.5. We know the mean, negative 18, divided by the standard deviation, 5.74. What do we get? 7.5 over 5.74. 1.5. 31. 1.31. So the large sample approximation will have what distribution? Normal, specifically standard normal. Since we are performing a two-tailed test, the rejection region will be on both sides. The area under the curve corresponding to each of the rejection regions is, you told me, 0.05 alpha over 2. If I find one of the two critical values, I can find the other by simply multiplying -1. Yes? How do we find the critical value? Which one should we pick? The one on the right or the one on the left? Up to you.
Wait, what is the mean of the distribution? Be 18?
No, it's standardized, so it's 0.
Oh,
Now, over here, earlier, when I accidentally put 0, that should have been, approximately 18. But over here, it's 0 because I'm standardizing. So what should the critical value, which one should we do on the right? Right is better. Or how do we find that critical value? What did we use last time?
We use R, which is
We didn't use R. We used R for the exact test. For the last sample approximation, we used inverse norm, the calculator. So option number 3, we have to specify the area below always. What is the area below the positive critical value? Is the area above is 0.05, the area below is 1 minus that. So you have 0.95. Mean is 0, standard deviation is 1, enter. The critical value on the right hand side is 1.645. The one on the left hand side would be negative 1.645. Where does our test statistic lie? Closer to 1.645. So in terms of a graph, if you look at this, this looks very similar to what we did earlier, right? All we are doing is taking that exact value and approximating. So the graph should look pretty much the same. Last time it was closer to the upper end point of 30. Yes, because we got 25.5. Here it is 1.31. Did the test statistic fall in the rejection region? Yes, no, maybe? No. The statistic did not fall in the rejection region. Should we reject the null? No, the conclusion is the same. Which means counseling doesn't help. The critics are right, yes. The only way we can proceed and test the effect is if this were to be significant. If the test statistic fell in the rejection region on the right-hand side, then after is bigger than before. Counseling helped. If it fell on the rejection region, on the left-hand side, counseling made it worse. But it didn't fall on either side, right in the middle, so it's useless. This is artificial data, people. Yes.
Is it just a coincidence that the 1/2, the 24.66, that number is also the mean for the 51 minus 18? Is it always going to be the mean, or is it just a coincidence?
Which one are you talking about?
The 18,
The 18
yeah, it's
is,
also the mean, so, but is it just a coincidence? that
I
it's-
used to be.
No, because you told us to use. the
Oh,
five.
over here, this is a
Yeah.
coincidence. Yeah, yeah.
Okay.
Yeah,
I'll
yeah.
write it down.
Oh, yeah, I used the mean over there
Yeah, I
for
know.
this correction factor.
That's
That
just-
is a coincidence.
Okay.
Okay, good question though. That just happened. We
Just
got
happened
lucky
to be
there.
that way.
How do we find the p-value for the large sample approximation? What did we use last time? Very good. We used normal CDF. So second bars, number 2. This is a two-tailed test. So keep in mind, for a two-tailed test, p-value is the area above the absolute value of test statistic multiplied by 2. If it is a right tail test, it is the area above test statistic. Left tail test, area below test statistic. Since it is a two-tailed test, we want to find the area above the absolute value of the test statistic, multiply it by 2. Normal CDF, the test statistic is 1.31. All the way up to E99. Mean 0, standard deviation 1. I get 0.095. Am I done yet? No. Got to multiply that by 2. That gives me 0.1902. And you can see that this p-value is less than the p-value that we had with the exact test. In practice, which one would you use? Should you use this one or the original? The original one, because that's exact. So when you have the option between an exact test and an approximation, the exact test is more accurate. You may ask me, then why did you do all this? Right, good question. Because I wanted to teach you large sample approximation. And sometimes, if the sample size is big enough, then we can just stick with large sample approximation. Very good illustration. Solution to homework 2. If you look at it, my explanations and the answers, Every single problem had a large sum. That is, if you looked at it. Did we look at it?
Yes.
Every single sample was large. So you will see that the confidence intervals are very close to each other. Good? Okay.